Now let's look at another example problem. This is a lead code problem called the ones and zeros. So this is an instance of essentially a knapsack problem. So we are given an array of strings where the strings contains only ones and zeros, and we are also given two integers m and n. We need to find the maximum number of strings that can be formed using these m zeros and n ones. So you can think of, you have this m blocks of zeros and n blocks of ones, and then you can put them together to form each of the strings. And the goal is to find out the maximum of those that can be formed. So we have up to 600 strings, and each string length up to 100. And the m and n are kind of small, up to 100. So here is an example. So I encourage you to think about what is the answer. So with 5 zeros and 3 ones, how many of these 5 strings can be formed at the most? So we can form 4 of them. So I guess if we are to do it manually, we'll probably do a little bit like a greedy, because this only use a 1 0 and 1 1. So we form this 2, and then we form this 2, and then we add this. This would use 1 1 1 3 ones, and 1 2 3 4 5 zeros. So that's exactly what we used up everything. So I guess, yeah, if we add a few more 1 and zeros, the answer should be the same, because forming all 5 of them would require at least 4 more ones and 2 more zeros. But in general, this greedy may not work, because 1 and 0 may be imbalanced, so there may be, they're just, you can't guarantee greedy will be correct, so you have to do it systematically. So this is it's like knapsack problem. We are picking things, put into the bag, where the bag have a capacity. But in this case, the constraint is actually on 2 dimensions, both on number of ones and number of zeros. And the value of each string is just 1, so that's what makes it a little bit easier. So this can be solved using dynamic programming. So I encourage you to write down the DP relations, and then the definition of what your DP state you want to be, and the recursive relation, and basically solve it. So the first So the first approach is the more standard one. We use a 3-dimensional. I guess it's not necessarily more standard, but it's sort of the most natural way to think about it. Is we use a 3-dimensional array that store the number of strings that can be formed when we consider only the first k strings, and we only use I zeros and J 1. So then the recursive relation is we will go through the starting from no string, which everything will be 0, and then we look at each string, look at the k string. So if it has x zeros and the y ones, then the dp kij, there will be 2 cases, right? We either do not use the k string, so then that will be dp k minus 1 ij, or we try to form it, then that would be dp k minus 1, I minus x, and j minus y. So of course, this part can be used only when I is greater than equal to x and j is greater than equal to y. So there are quite a few typo here. So then we can convert this into code. So this is implementation of this idea, we have 3-dimensional arrays, and again we are using +1 on each of them. So yeah, this is in Java code. So we count the number of zeros in the string, and this then n1 is number of ones. Then we have so this is a two-way loop over all ij's, and we first set dpkij equal k-1ij, and then when I and j are bigger than this, then we will take the max. So that solves this. So let's look at a little bit of the complexity here. This will be, yeah, I guess all of this will be the same thing. So m times n times the length. For this question is 100 times 100 times 600. So that's totally acceptable. So we next will look at a version which try to just use 2D array. So instead of having one dimension for the number of string we've considered, because we'll keep adding a new string into this consideration. So technically we can reuse a 2D array. So we can just use the dpij, which store the number of string that can be formed using I zeros and j ones. And the meaning of this array will be dynamic as we each time consider one additional string. So when we are considering the first string, then the array is the number of things we can form only using the first string, and then we do that. So actually doing it in 2D is a little bit challenging, because when you do this, you don't have this clear separation of dpkij and dpk-1ij. So this is implicit. But then if you directly just get rid of this line and do this, get rid of the k, then you run into the problem that this will also consider the case that the same string is formed again and again. So because so then you have to remember for each of the, if you do it this way, you have to remember for each of the value, is it already used the current string or it has not? So that's a little bit messy, but there is a way actually to get around that problem. Here is a way of using 2D array. So we loop over all strings, we count this, and what we are doing is instead of going up on the indices I and j, we are actually going down. So we start from the biggest number and then we go down. And what happens here is once we consider a particular value, a particular dpij where we use this string already, then it's guaranteed that these will not be used to consider it's guaranteed that the same string will not be considered twice because we are going down. So then this part is dpij is guaranteed to be the old value. It's guaranteed to be this dpk-1ij, this part. And this part is at this point, because we have not updated dpi-m1 j-m, so then this part is also guaranteed to be dpk-1 this. So by going down, we avoided the potential problem of counting the same string multiple times. So I actually don't remember where I got this code from. I might have copied it from somewhere because this idea of going down, I actually didn't. I didn't use this before, so I find this is a fairly elegant solution to the problem. Okay,